Hey everyone. So I'm recording from home today. I wanted to give you the last little bit of information about the skeletal system. So today I'm going to talk a little bit about joints and the movements that you can have at different joints in the body. All right, so first thing we need to understand is that we can classify joints structurally. So that means based upon their structure. So the three major classifications, structural classifications of joints are fibrous, cartilaginous, and synovial. And they kind of are descriptive of what they actually look like, right? So fibrous joints are ones that have a lot of like fibrous connective tissue holding them together. Cartilaginous joints are held together with cartilage, and then synovial joints are those that have like an entire synovial cavity that surrounds them. All right, so we can also classify joints functionally. So instead of just looking at them by their structure, we can look at them by how they function. So these are a whole nother set of classifications and they are overlapping, right? So the functional classifications of joints are synarthroses, which means no movement at all happens at that kind of joint, a synarthrosis. Amphiarthroses, which have a little bit of movement in them, and then diarthroses, which are freely movable joints. Right, so whether a joint is going to be considered a synarthrosis, an amphiarthrosis, or a diarthrosis has to do with how it functions, right? And the other ones that we were just looking at on the previous slide had to do with what they look like, their structure. So structural classifications and functional classifications are different. You should know what each of these different classifications means and also understand that they could be overlapping. Okay, so let's start out by looking at fibrous joints. So this is a structural classification of joint. So fibrous joints are ones that do not have a synovial cavity. We'll look at what that means in a minute. It means that the bones that are held together at this joint are held together with fibrous connective tissue. A lot of times, fibrous joints are synarthrotic or have very little movement in them, right? So different types of fibrous joints would be like sutures in your skull. So that we talked about how the skull bones are fused together with these type of fibrous joints we refer to as sutures. Syndesmosis, we'll look at that in a second, and a gomphosis. All right, so here's a little bit of what a suture looks like. So we can see that in the bones of the skull, they're fused together with fibrous connective tissue. Hopefully those bones don't move independently of one another, right? So that joint is a fused joint with no movement. So we would consider that structurally to be fibrous because of the structure of it, and then functionally synarthrotic because it does not move. So that's a synarthrosis. All right. Other fibrous joints here. So the one on the left of your screen there, looking at the joint between the tibia and the fibula in your leg. This is a fibrous joint as well because we've got that interosseous membrane, that sheet of fibrous connective tissue that's connecting the tibia and the fibula together. Functionally, this is considered an amphiarthrosis. So there is a little bit of movement between those two bones, right? So they don't move freely and independently of one another, but they do kind of slide around each other a little bit, and that's how you can get rotation of your leg. And so that's a fibrous joint, but it is considered an amphiarthrosis because there's a little bit of movement there. Right, another one here is a gomphosis. So gomphosis here, you're looking at kind of a cross section of a tooth in its socket in the jaw. So that's a type of fibrous joint because that tooth is being held in place with fibrous connective tissue. So periodontal ligament that holds that tooth in the jaw. That one is considered a synarthrosis because again, hopefully your teeth are not wiggling around in your jaw. If they are, then that's a problem. Okay, so moving on to our next structural classification, which are the cartilaginous joints. So cartilaginous joints, again, no synovial cavity here, and instead of fibrous connective tissue, we're going to go from bone to cartilage to bone. So there's going to be cartilage that's connecting the two bones together. And there are two different types here, so we can look at synchondroses and symphyses. All right, so the first one here on the left-hand side of your screen is the synchondrosis. So synchondrosis would be what we see at the epiphyseal plates or the epiphyseal lines in an adult. So where the bones are still growing, so the epiphyseal growth plates, we have bone, Then we've got cartilage, hyaline cartilage, and then we've got more bone. So where that kind of borderline between the bone, the cartilage, and the bone, that's considered a synarthrotic joint. So no movement there, and it's a cartilaginous joint because it's cartilage that's holding the two bones together. On the right-hand side of your screen, we can see an example of a symphysis. So a symphysis is the one that you're seeing there's the pubic symphysis. So between the two pubic bones, they're going to be held together by a type of cartilage called fibrocartilage. So the fibrocartilage is really tough cartilage. This one has a tiny little bit of movement to it. So this one we consider an amphiarthrosis because there can be movement between those pubic bones. Usually, really that movement is limited to childbirth is the only time when those pubic bones are really moving independently. Okay, moving on to our last sort of structural category of joints, and those are the synovial joints. And synovial joints is probably realistically what you think of when you think of a joint. So this is where two bones are coming together and they're moving. So all the joints that are allowing my fingers to move around, all the joints in my wrist, these are synovial joints, right? So there's a synovial joint as one where we have ligaments holding bones together, and those ligaments are going to be forming an entire cavity around the place where those two bones meet. And that cavity on the inside is covered with synovial membranes. So these are connective tissue membranes that create synovial fluid, which is a fluid that's going to kind of bathe this bone on bone area, so that the two bones don't rub against each other and cause pain. All right, so we can see in this picture a little bit the synovial membrane that's lining the inside of that synovial cavity. That those cells in there are creating the synovial fluid, and then that synovial fluid is what's creating cushion on the inside of that joint. Right, so here in this picture, we're looking at your shoulder joint, so we can see the scapula articulating with the clavicle and the humerus there, creating that shoulder joint. So in this picture, looking at it from the outside, we can see a lot of the ligaments that are holding these bones together. And then underneath those ligaments is where you would find the actual synovial cavity where all that synovial fluid is. Right. Also associated with joints like this, a lot of times we find bursa. So bursa are basically like little tiny joint pillows. They're little pillows of fluid that you find in your joint that help cushion the bones so that the joints can move freely without the bones bumping up against each other. They reduce friction and thus increase movement within the joints. All right. Um, Also, right here, you're looking at the knee joints. You're kind of looking down onto the proximal end of the tibia. Um, in the knee joint, we have menisci. So menisci are these discs of protective tissue that are going to cushion a joint. So especially joints like your knees that bear a lot of weight. So there's a lot of weight pushing down on your knees with every step that you take. The menisci that are in between those two bones, so in between where your femur comes down and hits your tibia, we need to cushion that so that those two bones aren't kind of hitting against each other in a painful way. So you've got a lateral meniscus, which is on the lateral side of the joint, and a medial one that's on the medial side of the joint. All right. Also, we talked about the fact that ligaments are important for holding joints together. In this particular joint, again, we're still looking at the knee here. We can see some of the important ligaments that are holding this one together. So the anterior cruciate ligament is probably one you've heard of. You've heard of your ACL before. So that's a ligament that crosses from the front of the knee joint to the back. And then you also have a posterior cruciate ligament that crosses from the back to the front. And so these ligaments cross over each other. Cruciate means cross. So anterior cruciate ligament and posterior cruciate ligament cross over one another and help to hold that joint together. All right, here's a side view of that knee joint. So we can see all the complexity that's going on in there. So we've got the entire synovial cavity that's surrounded by all those ligaments, the synovial fluid that's on the inside, the ligaments that cross in between the two bones of that joint, and also bursa that are going to be there helping to protect the joint and reduce pain. All right, so now we're going to get into the different types of synovial joints. So synovial joints are the most common joints in your body. We've got tons and tons of these, and they all have different movements to them. So a hinge joint is a synovial joint that hinges. So think about like your elbow, right? So your elbow is kind of like a hinge, like a door hinge. So we've got this hinge action to it. It's usually only movement in one direction. So that would be your elbow would be an example of that. A pivot joint is one where we have rotation. So you also have a pivot joint in your elbow, right? So that pivot joint is where you can kind of see in this picture here where the head of the radius rotates around the radial notch of the ulna. And so that allows for movement of your forearm. So the fact that you can kind of you rotate your forearm around is because of this pivot joint between the radius and the ulna. All right, here's a saddle joint. So a saddle joint is where the smooth articular surface of one joint is kind of saddle shaped. So this type of joint causes movement in three different directions. So when you think of a saddle joint, I want to think about your thumb, right? So your thumb, you can kind of move all around in three different directions, and that's because of the shape of the two bones that are coming together to form that joint. So it's mostly between the trapezium of your wrist and the first metacarpal of on your thumb side of your hand. All right. Next is a condyloid joint. So condyloid joint, this one is similar to a saddle joint, but instead of being in three different directions, it's really just in two directions that we get movement. So the condyloid joint, think about your wrist. So the fact that you can kind of rotate the wrist forward and you can rotate it side to side a little bit, that's a condyloid joint. All right, and then ball and socket joints here. So ball and socket joints are freely movable joints. So these are the most highly movable joints in the body. So you've got ball and socket joints. The one that they're showing you in this picture here is your hip joint. So your hip is considered a ball and socket because the femur fits into the acetabulum of the os coxa in order to create this kind of ball and socket movements. Very highly movable joints here. You also have ball and socket joint in your shoulder. Okay, planar joint. So planar joint is mostly to do with flat surfaces sliding past one another. So in your tarsal bones, you have a lot of these planar joints where the cube-shaped bones kind of just slide past one another. So we get slight movements here, back and forth, side to side, but not super highly movable. All right, so think about what type of joint is a freely movable joint and what type of joint has very little movement. So these are structural categories of joint here. I'm asking which ones have what type of movement. All right, so which one's going to be freely movable? That's going to be a synovial joint. So synovial joints are usually the most highly movable of the joints that we have. As far as little movement, those could be the cartilaginous joints. Even some fibrous joints can have a tiny bit of movement, but for the most part, that's cartilaginous joints that have little movement. Okay, here, match the type of joint with an example of that kind of joint. So take a look at through these different types of joints here, and I'll give you a second. So saddle joint, ball and socket, condyloid, hinge, and pivot, and think about what are some examples of those type of joints in the body. Right, so if we start with the saddle joint, so let's start with the saddle joint. What do you think? Yeah, that's going to be the thumb. So the saddle joint is like the joint for your thumb. So the ability to move your thumb all around like this makes it a saddle. Ball and socket, that one's going to be the hip. So the hip is a ball and socket joint. Condyloid, condyloid. Yeah, that's your wrist. So condyloid joint would be the wrist. The fact that you've got a little bit of movement here in the wrist. A hinge joint. Yep, your elbow. So your elbow is a hinge joint. And then a pivot joint would be, yeah, D, that's radius to ulna. So that's what allows rotation around your forearm. All right, very good. All right, so next I'm going to go over a few selected joints of the body. So just some kind of basic example joints so that we can understand how they work. These are really important joints that you should know a little bit about. So we're going to go through these one at a time, starting with the temporomandibular joint. So temporomandibular joint is this one right here. So it's the joint that's formed between your mandible and the rest of your skull. So this is the only movable joint in your skull. It should be the only one that's moving. And it's what allows you to talk and chew and do all the things that you want to do with your mouth. So we can see that this is a synovial joint. So we've got a synovial cavity that's kind of surrounding. Let me highlight here with my pen instead of pointing at my own face. All right, so we've got a synovial cavity here that's surrounding where those two bones come together. We've got hyaline cartilage covering the ends of the bones, and then we've got synovial fluid that's bathing that joint so that we can keep it well protected. All right, moving on to the shoulder. So shoulder joint is a ball and socket joint, which means it's a synovial joint. This one is a pretty complex joint. It is the most freely movable joint in your body. It's basically because the socket of the glenoid cavity is a very shallow socket for the ball of the humerus to fit into. And that means that you've got a lot of movement of the humerus around that socket of the glenoid cavity of the scapula. Right, so again, both bones, both the ends of both bones are covered in hyaline cartilage, and then we've got synovial fluid that's wrapping itself around inside that synovial cavity to bathe the joint. All right, moving down to the elbow. So the elbow joint is a hinge joint, again, a synovial joint here. We've got lots of ligaments holding these two bones together. We can see some bursa here. So again, bursa are little kind of like liquid pillows that are helping to protect the joint. Right, and then moving down to the hip. So you can see the hip is also a ball and socket joint where the head of the humerus fits, or I'm sorry, the head of the femur hits into the socket, which is the acetabulum of the os coxa. This joint is fairly movable, not quite as movable as your shoulder joint, but still a highly movable joint. All right, and then down to the knee. So the knee is first and foremost a hinge joint, right? That's the primary movement that it does. It is also the largest and most complex joint in the body. So knees are kind of ridiculously complicated. We walk around on two legs, which means that all of the weight of our body is being put down on these knees. And then we have to balance on those two legs, and we have to make sure that those knees are going to be stable and holding the entire weight of the body. So they're held together with a lot of different ligaments. There's a lot of cushioning between the two bones here. And then we've got the patella there, our largest sesamoid bone that's acting as a protector for the joint underneath. So we can see a whole bunch of these ligaments that are holding the joint together and protecting that joint and hopefully keeping us up on 2 feet. Here's a posterior view of it so that we can see some of those ligaments a little bit better holding the joint together. All right, so let's talk a little bit about what happens as we age to our joints. So no surprise here, they do not work as well as we get older. So if you live long enough, you will definitely get osteoarthritis. So osteoarthritis is what happens to our joints as they age. So usually that hyaline cartilage that's on the articular surfaces of the bone starts to go away a little bit. We get a little bit less production of synovial fluid. And so you start to have some painful joints, right? So the bones are not as well protected. You can kind of feel them rubbing up against each other a little bit, which can be painful. All right. If the joint deteriorates very, very badly, then we would have to replace that joint. So arthroplasty is when we take out the existing joint and replace it with an artificial joint. Hip replacements and knee replacements are pretty common as we age. So here you can see the kind of the before of a hip replacement where you would have to make these cuts to basically remove the acetabulum of the os coxa, remove the head of the femur, and then replace those um, with artificial pieces. So here's what the artificial hip would look like. So you can see that artificial acetabulum, the artificial shaft, and the head of the femur, and how those two would fit together in the patient. If we do the same thing for a knee joint, again, we would have to remove the surfaces, the articular surfaces of both the femur and the tibia and the patella in this case, because we've got 3 bones coming together here. and then replace those with artificial pieces. And hopefully those artificial pieces are going to be able to slide sort of smoothly across one another so we can get movement in that joint, right? That's the whole idea, is to have movement without pain in the joint. All right, so let's talk really quickly about some joint movements here. So we can break our movements down into four major categories. So gliding movements, angular movements, rotational movements, and then some special movements. So gliding is where we've got just back and forth, side to side. Angular is where we're increasing or decreasing an angle. Rotation is when we're moving around, and then we'll talk about some special movements towards the end here. Okay, so gliding movements are sliding back and forth and side to side. So your intercarpal joints, for example, so the ones we kind of already talked about, these in your wrist, those are considered gliding movements. So we're just sort of gliding back and forth and side to side. All right, angular movements are ones that are going to either decrease or increase an angle between two bones. So flexion is decreasing of an angle. So if I lift my arm here, and we can see I'm kind of creating a 90-degree angle with my arm. If I do this, that's flexion because I'm decreasing the angle here. If I do this, that's extension because I'm increasing the angle. So flexion is always decreasing the angle. Extension is always increasing the angle, right? Abduction and adduction. So abduction is to take away. So think of if someone gets abducted, we take them away. So take away from the midline. So if I lift my arm like this, I'm abducting it. I'm taking it away from the midline of my body. If I adduct, and then I add it back to the midline. So adduction is movement towards the midline. And then circumduction is in moving a body part in an entire circle. So if I do a kind of windmill motion here with my arm, then that would be considered circumduction. All right, so here's some pictures of those. So flexion and extension, again, decreasing or increasing of the angle of that joint. Abduction and adduction, which means either take away from the midline or add back to the midline. So abduct is take away, adduct is add back to, and then circumduction is a full-on circle movement of a particular joint. Okay, so circumduction is a little bit different from rotation. So rotation involves rotating around its own axis. So rotation of the head, right? We can do rotation of the head by turning it side to side. I can rotate my arm, I can rotate my leg in addition to circumducting. So rotation is a more central movement around one central axis. All right, and then some special movements here. So inversion, eversion, dorsiflexion, and plantar flexion. So inversion is movement. These are mostly for the feet. So inversion is movement of the feet medially. So if you turn like the soles of your feet towards one another, that would be inversion of the feet. Eversion is if you turn the soles of your feet outward. Dorsiflexion is if you bend your feet up. And plantar flexion is bending the feet down, sort of pointing the toes downward. Right, so there's some pictures of that. So inversion is the soles of the feet turn medial. Eversion is soles of the feet turn lateral. Dorsiflexion is toes pointing up, and plantar flexion is toes pointing downward. Okay, a few more special movements here. So supination is moving the palm upward. Pronation is moving the palm downward. So supine, prone. Supine, prone. And then opposition, this one usually just refers to the thumb. So the fact that my thumb can do this and kind of reach across my hand makes it opposable. So that's opposition of the thumb. All right, so there's pronation and supination, and then opposition. All right, some questions here. So the only movable joint in your head would be, yep, that's this one. So temporomandibular joint is the only movable joint in the head. The most complex joint in the body, it's your knee. So your knee is definitely the most complex joint in the body. There's a lot of moving parts there, and it's very complex to hold that knee joint together and bear all the weight. And the only named sesamoid bone in the body is your patella, right? So the patella is the only named sesamoid bone. You have lots of sesamoid bones. They tend to form in joints just to protect the surfaces of those joints, but usually they're too small and we don't really bother naming them. All right, and then some definitions here. So define adduction and abduction, flexion and extension, and define a gliding movement. So adduction is to add to the midline or bring to the midline. Abduction is to take away from the midline. Flexion is to decrease the angle of a joint. Extension is increasing the angle of a joint. And a gliding movement is when two bones slide past one another. All right, so hopefully that was helpful. Let me know if you have any questions about joints.